In this example, we're gonna discuss how to take into consideration the time for a jam, and which is the average downtime per jam, as well as how often does this happen. How many parts does this happen? So we have a synchronous assembly machine, has 80 stations and must produce at a rate of 400 completed assembly per hour. Average downtime per jam is 2.5 minutes. When a breakdown occurs, all subsequence, including the feeder, will stop. The frequency of breakdown of the machine is once every 50 parts. So how does this jam affect the assembly head? And would you be able to cope with the assembly system? Yes or no? One of the 80 stations is an automated system that uses a feed selector. The component fed into the selector can have one of the possible orientation, each with equal probability, but only one of which is correct. So the question would be, part rejected by the selector are fed back into the hopper. What minimum rate is it possible in order to make sure we're keeping up with the assembly machine? So to start with, we need to produce 400 completed assembly per hour. So we need to produce 400 units, finished unit per hour. Okay, and so this will take us to literally to the time needed per assembly. So TP equal 60 divided by 400. So this is literally 0.15 minutes per assembly or finished unit. Okay. However, this time it includes a jam, because as a finished unit we only care about how much we're managing to do at the end of the day rather than how much time is gone for a jam. So TP is equal TC plus F, which is the probability of jam, times jam time. So this will mean 0.15 is equal to TC value, which we're not aware of yet. And this jam is happening once every 50 units, so once every 50 parts, times 2.5 minutes per jam. Okay. So TC value is equal to 0.1 minute per assembly or per unit. So the jamming time here in this example is equal to 2.5 minutes every 50 times. So per times is equal, so the jam time is equal to 2.5 minutes divided by 50. So this would be our value. Okay. So the RC value, which is production rate, is 1 over TC is equal 10 assembly or 10 finished unit per minute. So how far we do things. Okay. So what would be the minimum value in order to make sure we're coping with the assembly head? So as it's been mentioned, that 20% or only 1 in 5 possible orientation will make it through. So the minimum F theta is equal to 0.20 times F is equal, okay, 0.20 times F is equal 10 assembly unit per head. Okay, so the feed rate equal 50 parts per minute. 50 parts per minute. So if we manage to do at this rate, the feed selector, we will manage to keep up with the assembly machine. The question is, what's the minimum rate must the feeder deliver component? So let's go over it in a different way. So if the feeder is delivering 50 parts per minute, and only 20% of those are in the correct orientation, so what's remaining of those is 10 parts per unit are fed into the system. So this is the minimum we need to feed into the system in order to make sure we're capable of meeting our values.